Assalamu alaikum, doctor.
Walaikum salam.
You still have no information about the backtracking?
My dear, so far I don't get any information about backtracking. Inshallah, we will let you know. Once it will be decided, inshallah, we will give the announcement in the blackboard.
Okay. Thank you, doctor.
Clear? Okay.
Clear.
Yes, in the last class we finished the first one. Now we have to go to the second problem. Read the question. My dear, please take your calculator. I need the answer from your side. Clear? So please take your calculator and I need the answer from your side. Don't see the answer from the slides. Just to tell your answer, what you got in your calculator. Okay, read the question. When 230 volt is applied across the wire that is 14.1 meter long and has the radius of 0.3 millimeter radius, and the magnitude of the current density is given as 1.98 multiplied by 10 to the power of 8 ampere per meter square. Find the resistivity of the wire. That means what are the information given in the question? They give the potential. They give the potential detail. What is the potential? Capital V, it is equal to 230 volt. And what is the length of the wire? 14.1 meter. And what is the radius of the wire? The radius of the wire is given as 0.3 millimeter. So we have to convert it to meter. So I have to multiply by 10 to the power of minus 3 meter. And then the current density value is given. What's the value? 1.98 multiplied by 10 to the power of 8 ampere per meter square. So what we have to find? We have to find the resistivity of the wire. So we have the formula for the resistivity, and you can just first write the formula. What is the formula for resistivity, my dear? So we have the formula for the resistance R, which is equal to rho L over A. Am I right? Am I right or not?
Yeah.
Okay. Now, if you rearrange this equation, you will get the information about the resistivity. So could you please rearrange this equation in terms of resistivity? Resistivity rho, which is equal to R multiplied by A divided by L. Am I right? Am I right or not?
Yes, doctor.
Okay. Is there any information about the resistance? Because area you can calculate from the resistance, sorry, radius. Because if you just see the cross-sectional view of the wire, it is like a area of the circle. So area of the circle is exactly pi r square. So you have the radius, so you will get the area. And the length of the wire is already given as 14.1 meter. Now, the only one parameter is missing here is nothing but our resistance. Is there any information about the resistance here? Is there any information about the resistance here? So we have to find the resistance. My dear, we have the Ohm's law. What is Ohm's law? V, which is equal to IR. Am I right? Am I right? Therefore, my R, which is equal to V over I. Am I right? Am I right or not?
Yes.
So if you take this R, if you substitute the value of R here, what should be your formula? My formula for the resistivity becomes V A over I multiplied by L. Am I right? Am I right? Now you can see what are the parameters in the given. Voltage is there. Area you can find by using the radius. Length is already there. Is there any information about the current?
No.
Is there any information about the current? No. But we have the rule of the current density. What is the formula for current density? Current density, which is equal to I over A. Therefore, I, which is equal to J multiplied by A. Am I right? So I can take this I. If you substitute here, you will get the resistivity formula as VA over JA multiplied by L. Am I right? Am I right?
Yes.
Yes, cancel L with
Now area and area get cancelled. What is remaining? My voltage is there. Current density is already given in the question. Length of the wire is given. So you can directly substitute the value rho, which is equal to, what is the value of the potential? 230 volt divided by what is your current density? Our current density is 1.98 multiplied by 10 to the power of 8. And what is the length of the wire? 14.1 meter. So could you please tell me the answer? When you substitute the value in your calculator, you will get the final answer. Could you please tell me the answer? What is the answer?
8.23.
8.23 multiplied by 10 to the power
minus
of
8.
Because if this 8 will go to the top, it will become 10 to the power of minus 8. What is the unit for the resistivity? Ohm meter. Clear, my dear? So how many formulas we used here? We use the formula for the resistance in terms of Ohm's law. From the Ohm's law, we calculate the resistance, we substitute. And then current is not there because in the question they give the information of the current density. So I can use the formula for current density. So the main formula is this. From the formula, we derive the formula of resistivity, and resistance we calculate from the Ohm's law, and the current we calculate from the current density. And finally, when you substitute, your area get cancelled, and remaining parameters V, J, and L is there. That means V is the voltage, J is the current density, L is the length. When you substitute, you will get the answer. Clear? Clear, my dear? Clear?
Dear doctor.
Okay. Now, we have to go to the third question. We have to go to the third question. Read the question very carefully. Actually, in these questions, you have two subdivisions. So first of all, we have to read, we have to write what is given in the question. So a heater contains a nichrome wire which has the resistivity value of 5 multiplied by 10 to the power of minus 7 ohm meter. That means the resistivity value of the nichrome is given, which is nothing but rho 5 multiplied by 10 to the power of minus 7 ohm meter. And the length of the wire is given. What is the length? 5.85 meter. And how much potential you are applying to the wire? You are just, for example, if you consider this is a wire. So this is my wire. And I apply the voltage of 112 volt. So my dear, if you just see the wire have the cross sectional area, and also the wire have the length. This is the length of the wire, and this wire is the cross section of the wire. And how much potential you applied? 112 volt you applied. And when you apply this 112 volt, how much power it created? It created the power of 4000 watts.
4000.
So 4000 watt is generated in the wire. Am I right? Am I right or not?
Yes.
Now, by using all these things, what you are going to find in the first part of the question, you are going to find the cross-sectional area. That means we are going to find this shaded portion. This is the cross-sectional area. So we are going to find this. Clear, my dear? Understand? Understand?
Yes, doctor.
Okay. Now, we have the formula for the resistance. What is the formula for resistance? The question number A, we have the formula for the resistance, rho multiplied by L over A. Am I right? Am I right or not? Suppose in the question, the resistance will be given. Suppose if the resistance is given, you can directly find the value of A. Am I right? Am I right or not?
Yes, doctor.
But in the question, is there any information about the resistance?
No.
So what I am going to do, we have the power value. We have three formula for the power. What are the formula? Power P, which is equal to I multiplied by V. Power P, which is equal to I square multiplied by R. Power P, which is equal to V square over R. We have all these three formula. Now, based on the given, I can just use the third formula. Why? Because the power information is given. So I am going to write this formula here. So what is that rule? P, which is equal to V square over R. Why I am not using the first two? Because the current information is not given here. So why I choose the last formula? Because we are going to equate the resistance with the resistance. Because the resistance is already not given. But once you choose the third formula, you can rearrange this formula in terms of resistance. And then I am going to compare these two equations. So for the right now, I am going to take, this is my first equation. When I just rearrange the second, this power equation in terms of resistance, I will get R, which is equal to V square over P. Am I right? So I am going to take, this is my second equation. Clear? Clear, my dear?
Yes.
Okay, now I'm going to equate equation number 1 and 2. My left hand side of the equation, both are exactly resistance, so I can equate with the right hand term. So what is in the right hand side? I have rho L over area, which is equal to V square over P. Am I right? Now we are going to find the area, that means the cross section of the area. So could you please rearrange this equation in terms of area? Therefore, area which is equal to P multiplied by rho multiplied by L divided by V square. Now you have all these terms here. Could you please substitute the value here? What is the power of the wire? The power dissipated is exactly 4000 watt, and the resistivity of the wire is 5 multiplied by 10 to the power of minus 7, and then the length of the wire is given as 5.85 divided by our voltage is given as 112 the whole square. Clear? So when you substitute, you will get the area. Understand? Could you please tell me the answer? Could you please tell me the answer?
9.32.
9.32 multiplied by
10
to the
power
power of
minus 7.
minus 7. What's the unit for the area? It's meter square. So this is the answer for the first question. Clear, my dear? Clear?
Clear, Doctor.
Clear? Okay, now you have another problem also. You can see here what is given in the second problem. Instead of giving this 112 volt, how much volt you are going to give? How much volt you are going to give?
100.
If you just give 100 volt instead of 112 volt, and you have to get the same power, and if you have the same power, what should be the length? So now, my dear, in the first part, your length is already given as 5.85, and for this 5.85, you substitute 112 volt, and how much power it generate? It generate the power of 4000. Now, in the second question, what they said? You have to get the same power, but how much volt you have to substitute? How much volt you have to substitute? 100 volt.
100.
So if you set 100 volt for this power, what should be the length is needed? Because you no need 5.85 meter. Why? Because your voltage is small, and at the same time you have to get the same power. So what I'm going to do, again I'm going to use the same equation. What is the equation? Equation number 1 and 2 I am going to use, and left hand side and the right hand side of the left hand side of the two equations are exactly same. So I can use the same relation, rho L over area, which is equal to V square over P. Am I right? Am I right or not? Because the cross section of the area will not change. It will be the same value. We are talking only about the length of the wire. Suppose if you want to give 112 volt, what should be the length? And instead of this 112 volt, if you set 100 volt, you no need this 5.85 meter. Am I right? So what I'm going to do, I'm going to again use the same equation, but this time I'm going to rearrange this equation in terms of length. So if you rearrange this equation in terms of length, what you'll get? L, which is equal to A multiplied by V square divided by rho multiplied by P. Am I right? Now you can see in the second part they clearly mentioned you have to use the same dissipation rate, that means same power. So our area I am going to take from the first part. What is the power? The power of the wire generated is 4000. Therefore L, which is equal to 9.32 multiplied by 10 to the power of minus 7. And how much volt you are going to apply? Instead of 112 volt, you are setting 100 volt divided by the resistivity of the wire is given 5 multiplied by 10 to the power of minus 7. At the same time, how much power? You have to get the same power. So by the time, could you please tell me what is the length? What's the answer, my dear?
Second, Doctor.
My dear, what happened to others? Only I'm just hearing Muhammad voice. What happened to others? Are you sleeping, my dear? What happened to others? No. Yeah, you are with me, but why you are not giving the answer? Why you, Mr. Mohammed is giving all the time the answer? Why you are not giving your answer?
Teacher, I
copying.
have brothers around me. I can't open mic every time.
Okay, my dear. Okay, but when you have a class, you have to sit in the separate room. Am I right?
Yes, but sometimes my brothers
Okay,
come
no
to
issue.
my
It's up to you,
room.
my dear. My dear, listen. In the
We
class,
are
I
focused
need
with you,
everyone
teacher.
interaction. My dear, listen carefully. My dear, listen carefully. If you are in the classroom, I need the interaction of each and every student. That's what I am asking this question. It's up to you. If you are willing, give the answer. If you don't will, no problem. I have no issue. As a teacher, I am asking this question. Clear?
Clear,
Doctor,
doctor.
I check it.
Doctor, the answer
Ah,
4.66.
4.6 is what's the unit? Meter. So
Meter.
now you can see here, my dear, if you want to set 110 volt, how much length you need? If you want to set 112 volt, how much length you need?
5.85.
Okay. If you want to set 100 volt, what is the length you need?
4.66.
That's it. Clear. Because if the most important thing in the first part and the second part, you have to use the same power. In such a case, the length is this much length is enough. Suppose if the power will be different, it will be wrong. Clear. So please read the question
Doctor,
very carefully. Yes.
the area that you use that we found in the first part.
Yes, because according to the question, you are using the same wire. You can just read the question very carefully. You are using the same wire. So the cross section of the wire will not change for each and every question. Am I right? It will be the same for the first part and the second part.
Yes, yes.
Clear?
Clear, doctor.
Okay. Now let's become for the third question. Third question. What is given here? An unknown resistor is connected between the terminals of 3-volt battery. So that means we don't know the value of the resistor. It's an unknown value. So you connected this resistor with a 3-volt battery. Better I can just draw the diagram. I have a resistor and I just connected with how much volt battery? 3-volt battery. So what is the resistor? We don't know the value. But the power of the resistor is given. How much power this resistor generates? It gives the
0.707.
707 watt it generate. Now, my dear, again here you have two part, but only one question is given, because if you want to get the answer for this, you have to first get the answer of the first one. That means you have to get the value of R. Why? Because you just continue read the question. The same resistor is then connected between 12 volt. So in the second part, you are going to use the same resistor, but this time what should be the voltage of the battery? This time it is 12 volt battery.
12.
So what we are going to do, in the first part, I am going to find the resistor's value, and then I am going to use this resistor value here. By using the power, I am going to find the power. Clear? Clear, my dear?
Doctor.
Clear?
Okay, doctor, but the resistance, when we find here, it will be not different?
You can see, you can read the question, what is given here.
The same resistor.
That means the same resistance. What resistance you are going to use, you are going to substitute the same value here.
But doctor, the power will be different because the volt.
Of course, the power should be different. That's what we are going to find the power in this.
Okay.
Clear?
Clear,
So
doctor.
first part, when you connected 3-volt battery, you got 0.707 watt. But in the second part, you connected the same resistors with the 12-volt battery. By the time you will not get the same power. This time the power will be different. Am I right? So what I'm going to do, again, I'm going to use one of the formula from here. If you just see this three formula, current here, but only this formula, there is no current. Am I right? Am I right or not?
Yes,
Yes.
you are right, doctor.
So I'm going to use this equation, first part, for finding the value of R. So we have the formula power P, which is equal to V square over R. So I'm going to rearrange this equation in terms of R. Therefore, R, which is equal to V square over P. And what is the volt? You applied 3 voltage. That means 3 square over. And what is your power in the first part? It is 0.707. So when you apply this value, you will get the value of the resistor. Could you please tell me what is the value of the resistor? 3 square divided by 0.707.
I got 12.73.
73. What's the unit? It's ohm.
Ohm.
So now, what is the resistance value here? The resistance value is 12.73 ohm. Am I right? And
Yes,
how much
correct.
voltage you are going to apply? We are going to apply 12 volt.
12.
Previously it is 3 volt. Now we change. Again,
Same
I am going to use
formula.
the same formula. So
Yeah.
P, which is equal to V square over R, and this time I'm going to find the power of this circuit. So what is the volt? Here we substitute 12
12.
square. And what is the
Over
resistance
R.
value? Just before we find 12.73. My dear, listen carefully. If you made a mistake here, then the second part will be wrong. So you have to be very, very careful. Clear? So could you please
Clear.
tell me the answer?
The answer is 11.31.
31. What's the unit?
Watt.
Very good. That's it. Clear? Clear, my dear?
Clear, doctor.
We come for our last question. This is our last question of this chapter. My dear, the question wise it seems like very big, but it's very easy because you have 4 subdivisions. How many subdivisions you have? You have 4 subdivisions. My dear, if you made a mistake in the first question, then the remaining 4 will be wrong. So please, my dear, read the question, use your calculator properly, then only everything will be correct. Okay? So, okay, let's read what is given. A block in the shape of rectangular solid cross-sectional area of 2.7 centimeters square. That means you have a rectangular block. So I can just first draw the rectangular block. So this is the shape of the rectangle. So it is like a rectangular block. That means I have to draw this type of diagram. So I have a rectangular block, and this rectangular block has the area. How much area it have? It has the area of 2.7 centimeter square. Could you please convert this centimeter square to meter square? Because 1 centimeter, which is equal to 10 to the power of minus 2 meter. Therefore, 1 centimeter the whole square, which is equal to 10 to the power of minus 2 meter the whole square. So what should be the answer? 10 to the power of minus 4
meter.
minus 4 meter square. So if you convert the centimeter square to meter square, so what you will get? 2.7 multiplied by 10 to the power of minus 4 meter square. And then from the front to the rear length is 11 meter. My dear, listen carefully. If you see this block, this is the front side of the block. Am I right? And back side, it will be here. Am I right or not? If you see the block, this is because I cannot be able to draw the 3-dimensional picture. But if you see the block, this is the front side of the block, and back side, it's a back side. Am I right? So
Yes.
from the back side, from the front side to the back side, what should be the distance, my dear? The distance from the front side and the back side is given as 11.7 centimeter. Clear? Clear, my dear?
Clear, doctor.
Okay, so I can write my distance from the front side to the back side is 11.7 centimeter. So I have to convert it to meter. And then the resistance value is given. So the resistance value is given. So what is that value? 935 ohm. Now this block contains 5.33 multiplied by 10 to the power of 22 conduction electron per meter cube. So my dear, this electron has some, this block has some volume, and in this, because this is a this is a solid material, so it has more valence electron. So how many electrons you have in this block, my dear? N value. How many electrons you have? 5.33 multiplied by 10 to the power of 22 conduction electron per meter cube. Am I right? Am I right or not? So this many electrons you have in this block, and now you are setting the potential between front side and the back side. So I'm going to connect a battery to the front side of the block to the back side of the block. So how much voltage you are going to substitute? You are going to substitute 35.8 volt. So I have to write 35.58 volt here. So now you can see, my dear, what are the information given in the question? They give the area of the block, and they give the length from the front side to the back side is 11.7 centimeter, and the resistance is given as 935 ohm, and the number of electrons in this block is 5.33 multiplied by 10 to the power of 22, and the voltage across the front side and the back side is 35 volt, 35.8 volt. Now by using all these things, what are the things we are going to find, my dear? In the first question, what we are going to find? We are going to find the current. Am I right or not? We are going to find the I value. what you are going to find the second value? Current density. What is current density? J value we are going to find. What is your third question? We are going to find the drift velocity. That means it's VD value we are going to find. And in the fourth question, we are going to find the electrical field. So we are going to find the value of E. So my dear, listen carefully. If you made a mistake in the first question, it will affect the rest of the question. So please, my dear, use the formula very carefully, because current we have two formulas. What are the two formulas we have, my dear? Current I, which is equal to Q over T, and also current I, which is equal to V over R. These two formulas we have. Am I right? Am I right or not? So out of these two formulas, which formula you can use? Because if you want to use the first equation, you need the charge and you need the time. That information is not given in the question. So only this formula is enough. Am I right? So you can't be able to use this. Clear?
Clear, Doctor.
Clear.
Clear, my dear. Substitute the value. We have the voltage. How much voltage? We have 35.8. What is the resistance? It's 935 ohm. So substitute the value. Therefore, I, which is equal to 35.8 divided by 935. Could you please tell me the answer? Could you please tell me the answer?
0.038.
0.038. What is the unit? Ampere.
Ampere.
So if you want to convert into the power, no problem. What answer you got in your calculator, just write as it is. Okay. And now, what is your second question? We have to find the current density. My dear, what is the formula for current density? I divided by area. This is the formula. Am I right? Now, I'm going to take the I. I'm going to substitute here. And our area is already given in the question. So you can directly substitute the value. What is our current? 0.038 divided by our area is 2.7 multiplied by 10 to the power of minus 4. So could you please tell me the answer for the second question?
$140.7.
140.7. But what's the unit? The unit for the current is ampere. And the unit for the area is meter square. So this is the answer for the second question. Clear? Okay. What is your third question? Yes?
I said clear. So.
Oh, okay. Good. So what is your third question? We are going to find the drift velocity. That means VD value we are going to find. My dear, we have the relation connecting drift speed and the current density. What is the formula? NEVD. We have this rule. Am I right? So I am going to use this formula for this question, because why? Because the current density value just before we find. So I am going to rearrange this equation in terms of drift speed. Therefore, drift speed VD, which is equal to the current density divided by number of conduction electron and multiply by the charge. So what is our current density? 140.7 divided by the number of conduction electron is given in the question, which is nothing but 5.33 multiplied by 10 to the power of 22 multiplied by the charge value is the constant 1.6 multiplied by 10 to the power of minus 19. When you substitute, you will get the answer for the drift speed. Could you please tell me the answer?
0.016.
0.063. What's the unit?
No,
No,
Doctor,
Doctor.
16.
What?
0.016.
Could you please tell me again? 0.016.
0.016. Yes.
What's the third digit? Another
4.
digit. What is it?
4.
4?
Yes.
Okay, 4 and unit is meter per second. Clear? So this will, whatever it may be, you can just use
4.9.
Okay, no problem. Okay, no problem. Okay, I can write 0.0165 meter per second because the unit for the speed is meter per second. Clear? What is our last? We have to find the electric field. My dear, we know the formula. Potential, which is equal to electrical field multiplied by distance. We studied this. Am I right? We studied this formula in chapter number 25. Do you remember this formula?
Yes.
So here, according to this picture, our distance is the distance between the front side and the back side. So how I can write this formula? I can write this formula V, which is equal to E multiplied by L. Am I right? Am I right or not?
Right, Doctor. Yeah,
So
of course.
rearrange this equation in terms of electrical field E, which is equal to V over L. So the V is already given as 35.8. So 35.8 divided by what is the length? The length from the front side to the back side is 11.7 centimeter. So I can just 10 to the power of -2. So when you substitute, you will get the answer for the electrical field. Could you please tell me the answer?
$305.9.
305.9. What's the unit? The unit for the potential is V and the unit for the length is meter. Clear, my dear? Clear?
Okay, Doctor, can I write Newton per Coulomb?
Yes, that is also correct. If you want to write, because brother, electrical field has 3 units. The first unit is Newton per Coulomb. The second unit is voltage per meter. And the third unit is joules per Coulomb meter. That is also the unit for the electrical field. Joules per Coulomb meter is also the unit for the electrical field. So it's up to you. But according to the formula, my dear, listen carefully. If you want to write Newton per Coulomb, your answer is correct. But when you just see the formula, the potential unit is voltage, but the length unit is meter. If you write, that will be more perfect. Clear? Clear?
Yes, clear, Doctor.
Yes, my dear. Ask your question.
Doctor, I have a question about this formula.
Yes, this formula.
V equal to E multiplied.
My dear, in chapter 25, we studied the concept of capacitor. Am I right? You have 2 plates.
Yes.
And in this plate, you are saving positive charge. Am I right?
Yes.
In this plate, you are saving the negative charge. Am I right?
Yes.
So if you have positive and negative charge, you will get the electrical field from positive to the negative. Am I right?
Yes.
So if you want to find the potential between the plate, potential V, which is equal to electrical field multiplied by the distance between the 2 plates. Am I right?
Yes.
We studied this rule. Likewise, you can apply, because this is a conducting material. So it has some charges here, it has some charges that side. Am I right? So by the time, what will happen? The distance from the front side to the back side is nothing but my distance L. So I can use this formula.
Ah, okay. Makes sense. Thank you.
Clear?
Yes, clear.
Clear? Okay.
Yes.
So that's it, my dear. Chapter 26 is over. Now I am going to start chapter 27, and it's one of the important chapter, and this will be the last chapter for your semester. So this semester we consider from chapter number 16 to 27. So this will be the last chapter. Inshallah, I will try to finish the theory by today. In tomorrow we have one more class, and we will solve the problem by tomorrow. Clear? Understand? Yes. Yes, my dear, ask your question.
Doctor, next week, what we will do? We have more.
No problem. Well, let's first of all we will see how many questions we can finish. If I cannot be able to finish by this week, I will continue by next week. Suppose if I finish by this week, next week we can make it as a revision.
Okay.
Clear?
Clear, Doctor.
Okay. My dear, this will be the last chapter for this semester. The title of the chapter is circuit. My dear, listen carefully. In this chapter, you have 2 formulas, and apart from that, if you want to solve the problems, you have to see the circuit diagram and you have to frame the equation. So please, my dear, I'm going to explain clearly. Please listen carefully. If you have any question, immediately ask your question. Because if you want to get the correct answer, then your equation should be correct. So how you can get the equation? You will get the equation from the circuit diagram. Clear? So
I
this
think,
question
Doctor, we will study just 2 formula about the resistance, right, Doctor?
Yes, you are going to study the formula only for the resistance in parallel and series. But the remaining thing, you have to frame the equation. Clear?
Yeah.
Okay. So now the title of the chapter is circuit. What are the topics today we are going to discuss? Today we are going to discuss this many topics, but it's very easy. The topic wise it is 8 points, am I right? But it's very easy. So what are the things we are going to study? We are going to study some general information about what is EMF, just an introduction. And then we are going to study the concept of real EMF devices and ideal EMF devices. and then we are going to study two rules. What are the two rules? Kirchhoff's loop rule, Kirchhoff junction rule. My dear, this loop rule have another name, voltage rule. What is that? Loop rule is also called as voltage rule. Junction rule is also called as current rule. So please don't forget. Loop means it's related with the voltage. Junction means it is related with the current. And then we are going to study the concept of multi-loop circuit. If there is only one circuit, no problem. It's very easy. Suppose if the loop has many circuits, more than one circuit in a circuit, this is called as multi-loop circuit. So it is like a complicated circuits. So if you have a circuit more than one, then we have to say that circuit is multi-loop circuit. And then we are going to study the concept of resistors in series and parallel. And finally, we are going to have two equations in charging and discharging of the capacitor. You already did this experiment in the lab. Discharging of the capacitor, you finished, am I right? So I will recall that experiment and we are going to use that concept for the problems. My dear, listen carefully. Okay, let's come for the introduction about the cell and the battery. So in our day-to-day life, we are using this battery, am I right? If you have a battery, so for sure it has 2 points, positive charge, positive electrode, and then negative electrodes. So if you take a battery, you already studied the concept of battery in the chemistry. So I'm not going to explain that much detail here. I'm just going to give some small information. So if you take a battery or a cell, my dear, the battery and the cell in this chapter is related with a direct current, DC. So you have two types of current, DC current and AC current. If the current is producing by DC, then we have to say it's a battery. Clear? So all these chapters, all the informations what we are going to study from this chapter is related with the DC current. Clear, my dear? So what we are going to study? We are going to study the concept of battery. So if you take a battery, these two informations are very, very important, electrode and electrolyte. So if you take a battery, it has two terminals. One is positive, another one is negative. So, and these two terminals are a conducting material. So why we are using the conducting material? Then only the current will be passing through this. If it is not a conductor, current will not pass. Because we studied the concept of conductor, insulator, semiconductor, superconductor in chapter number 21. Do you remember that? Do you remember that, my dear?
Yes.
Yes, doctor.
So if you take a battery, yes, my dear.
Sorry, it's a mistake.
Okay, no problem. Okay, and then if you see, if you break this battery, if you just break a battery, what is inside, my dear? If you just break this battery, you can find inside some aqueous substance, which is called as electrolyte. And this electrolyte substance is it will have many free ions which will make electrically conductive. So in our house we are using this battery. Sometimes if the battery is gone, you can just open this battery. If you just break this battery, you can find inside some black colored material. So, and this black colored material is called as electrolyte, and this electrolyte is full of free ion material which will make it conductive. So this structure, for example, here I gave some picture, you know, and this is the internal view of the battery. This is the internal view of the battery. We will see only the positive terminal and negative terminal outside. That means your positive is here, your negative is here. What is inside? Inside you have all this information. Clear, my dear? You have some aqueous material and inside some reactions will be there. Understand? Clear?
Yes, doctor.
Yes.
Okay. Now we are going to learn what is EMF. Electromotive force. If you want to write in the shortest way, we have to say EMF. What is that? E stands for electro, M stands for motive, and F stands for force. So if you take a battery, the battery will have some EMF. That means it will have some force. My dear, actually this force is not a real force. From word wise, we are using the word force, but it is not a force. Actually, what is EMF? The definition for the EMF is given in this first box. You can just read what is given here. It is the potential difference between two electrodes of the cell. For example, you take this battery. Now, if you measure the voltage across this positive terminal and negative terminal, then that is called as EMF. You are not connecting this battery with the circuit. So you should not connect this battery with the circuit. So before you connect it with the circuit, if you measure the voltage between this positive and the negative electrode, and that is called as electromotive force. That information is given in these 3 lines. Clear, my dear? And the explanation is given clearly. You can see here what is written here. When the cell is not connected to a closed circuit, that means no current is in the cell. So before you connected the battery to the circuit, what is happening? No current will be there. Am I right? So if you measure the potential between the positive terminal and the negative terminal of the electrodes, and that will be the EMF of the battery. Clear? What is the use of the battery, my dear? It will give some energy. What type of energy? It will give the electrical energy. That's what we are using the battery. Clear? Clear, my dear?
Clear, Doctor.
Yes.
Okay, now we are going to study 2 resistance. The one resistance is indicated with a letter capital R, and another resistance is indicated, denoted by a letter small r. What is the difference between these 2? My dear, this capital R is the external resistance. For example, I am going to take one resistor. I am going to connect it with a battery between positive terminal and the negative terminal. Now, whatever the material you are connecting outside of the battery, that means if you just connect it, if you just go back, I'm going to take a connection, I'm going to connect it the resistor. That means externally I'm going to connect it. Okay, now if you connect the resistors, I have to use R. So this is the external resistance. My dear, when you connected a resistor outside, what will happen? Current is flowing through this. Am I right? Am I right or not? When you connected the wire with the resistors, what will happen? The current will be moving from positive to the negative. Am I right? Am I right?
Yes, doctor.
Yes.
It's a conventional current, because we are saying we have 2 types of current. In the last chapter I told you we have 2 types of current: conventional current and electron current. Conventional current always moving from positive terminal to the negative terminal, but the electron current is moving from negative terminal to the positive terminal. Okay, my dear? But in this chapter we are going to consider everything as a conventional current. So keep this information in your mind. Now you can see I have a battery and I have positive terminal, I have negative terminal. I'm going to make a wire. I just connected one resistor outside. So now what will happen, my dear? When you connected any conducting wire between this terminal, what will happen? The current is flowing. Am I right? Whenever the current is flowing, what will happen? The resistance will be there. Because of the resistance, the heat energy will be produced. Am I right? And not only outside, my dear, inside you have all this electrolytic material. Am I right? So inside you have some aqueous solution. My dear, outside you have external resistance. When you connect to the wire, when the current is flowing, what will happen? Inside this electrolytic material, another resistance will be produced. That is nothing but the internal resistance, and which will be denoted by a letter small r. Clear? Clear, my dear? So inside the aqueous material, that means inside this battery, you have the electrolytic solution, and that solution will produce another resistance, and that resistance is called as internal resistance, which will be denoted by a letter small r. But external, you have another resistance, and that should be denoted by a capital R. So that is the difference between the internal resistance and the external resistance. Clear? Clear, my dear? Clear
Yes.
or not?
Yes, clear. Thank you.
Okay.
Clear, doctor.
Now, okay, that's great. Okay, now we are going to study the concept of real EMF devices. My dear, here don't confuse by yourself. EMF means just consider it's a battery. Clear? What is EMF? EMF is a battery. So when it will be, whenever you are not connecting with the circuit, then you have to say it is a EMF. Clear? So now we are going to study the concept of real device and the ideal device. What is the real device? Real device, whatever, just read these points, just read these 3 lines. What is given here? An EMF device is said to be ideal if the voltage across the terminal A and B does not depend on the current. It flows through the EMF device. That means whatever the voltage you substitute, it will be exactly the same throughout the circuit. But when you come for the real device, what will happen? Because of the internal resistance, some drop will be there, some voltage drop will be there. That's what we have the equation V, which is equal to your EMF device minus the current with respect to the internal resistance. There will be some drop of voltage. You can see the graph in ideal device. What happened? You can see the voltage. It's exactly throughout the circuit, the current will be when you just draw the graph between the voltage and the current, it will be the constant value. But when you come for the real EMF devices, what happened? What happened, my dear? Some drop of voltage will be there. Am I right or not? It's because of the internal resistance. Generally, whatever the battery we are using, it's a real EMF devices, so you will not get the exact voltage. Clear? Clear, my dear?
Yes, doctor.
Okay. Now we just go for the two important laws in this chapter. Two important laws in this chapter. So please, my dear, listen carefully. So you have two laws. One is Kirchhoff voltage rule. Another one is Kirchhoff current rule. This voltage rule is called as loop rule, and this current rule is called as junction rule. Clear, my dear? It's a 1 mark theory question. Kirchhoff current rule is also called as Kirchhoff junction rule. Loop rule is also known as voltage rule. So please keep this information in your mind. Okay?
Okay,
Yes,
doctor.
doctor.
Okay. Now let's start with the junction rule. My dear, this junction rule is very, very easy. You can just read the information which is given in the slide. What is given here? At junction. What is the junction? See the picture. Here I have 5 branches. Am I right? What is the junction? This is my junction. Am I right? Where all the branches meets. So this, in this point, all these branches are meeting. Am I right? Am I right or not? So at the junction,
Yes.
sum of the current entering the junction is equal to the sum of the current leaving the junction. So if you consider this is the junction, how many currents in this branch? I have 5 currents. You can see the arrow mark. How many currents are entering the junction? How many currents are leaving the junction? Could you please tell me the answer?
Two-
According to this
two
picture,
entering that.
I have 2 currents entering. What are they? I1,
I1, I4.
V4.
I1 and I4 are entering. What are the currents leaving?
I5,
I5,
I3,
I3 and
I2.
I2. So you can write the equation. Then the sum of entering current. What are the entering currents? I1 and I3. So I1 plus sum, because they clearly mentioned the sum. So I1 plus I4, which is equal to how many currents are leaving? 3 currents are leaving. So what are the 3 currents? I2 plus
I3,
I3
I4.
plus I5. So this is the rule. Clear? So definition wise, it's very easy. At a junction, the sum of current entering the junction is equal to the sum of the current leaving the junction. Keep this point in your mind. Yes, my dear.
Doctor, how do we know, Doctor, I1 and I4 separate and the another sum is separate?
My dear, see the arrow mark. What is this arrow mark?
Down.
It is going inside. Am I right?
Inside.
And
yeah.
you can see these are the currents are going out. Am I right?
Oh, yes, you are right.
These 2 are entering. These 3 are leaving. So entering current must be equal to the exit current.
Exit current, yeah.
Clear?
Clear, Doctor.
Okay. So this is called as junction rule. Any doubt here, my dear? Any doubt here? Suppose if the circuit diagram will be given, you have to see the picture, you can write the equation. My dear, writing the equation is in your hand. By seeing the picture, you have to write the equation. Clear? Understand? Clear?
Understand.
Clear, Doctor.
Clear.
Okay. Now, my dear, actually, most of the problems what we are going to solve from this chapter is related with the voltage rule. This is an important topic. So please, my dear, could you please read? I have 2 boxes, and these 2 boxes are the definition for the voltage rule. So which one will be easy? You can take it into your account. Okay. But both are exactly correct. Now you can just read the first box, because the first box, when you just read, it will be easy to understand. So could you please read the first box? In a closed loop, see the circuit diagram. My dear, see this picture and please read line by line, word by word. Okay. So see this picture and please read word by word. In a closed loop, see this picture. It is a closed loop. Am I right? You can see I have a battery and I connected one resistance and then connected the second resistance and I connected third resistors, and then finally it will be closed with a negative terminal. Am I right? Am I right or not?
Yes, doctor.
So that means this loop is completely closed. Am I right? So that information is given here. So if you want to apply this voltage rule, your circuit should be a closed loop. If your circuit will be open, you cannot be able to apply. Clear? Clear? Okay. Now Could you please read this line? The sum of algebraic sum of EMF. What is the EMF? Your battery is the EMF. I told you already. Am I right? So if you have 5 batteries or 3 batteries, just add one side. So what is given here? Here you have 2 parts. One is left hand side, another one is right hand side. What is the left hand side? Left hand side, you have to take the battery. Right hand side, you can take the current and the resistors. The product of current and the resistor. So according to this picture, how many batteries you have? How many batteries you have? My dear, in this picture, how many batteries you have? That
One.
only one. So algebraic sum of EMF is equal to, that means I have only one EMF, so it should be indicated with the letter this E like structure, okay, which is equal to the algebraic sum of product of resistance and its respective current. My dear, you can just multiply these two, resistance, product of resistance and its current. So what you will get here? What you will get here?
R1I.
I multiply by R1 and it's a sum, algebraic sum. So plus, what is here?
R2I.
by R2.
I multiply by R2 and what is here?
I multiply by R3.
That's it. This will be your equation. Clear? And you have to consider the direction of the current in the battery. So that means your current is flowing in this direction. Am I right? Am I right?
Yes, doctor.
You got this equation? So if you have these type of rule, my dear, listen carefully. We are going to solve some problems with 2 batteries. Suppose if I have 2 batteries, you separate batteries on side and in the another side you separate the current and the resistance. Keep this point in your mind. Clear? Clear?
Clear, Doctor.
Okay. Now I will just explain the multi-loop and then I will come back to the series and the parallel. Okay. Okay. Now, my dear, I will explain this circuit. This circuit is an example for multi-loop. Why multi-loop? You have 3 closed loop. Am I right? What are the 3 closed loop? My dear, see this picture. This is my first closed loop. Am I right? This is the first loop. Am I right?
Yes,
Yes.
you're right.
And what is your second loop? This is my second loop. Am I right?
Yes.
Yes.
And what is your third loop?
All of them.
Clear? Clear, my dear?
Yes.
Okay, now I am going to explain how we got this equation. So I am going to save this picture in the second slide. Now I am going to explain loop by loop. My dear, listen carefully. If you have any doubts, please ask your question immediately. Okay? Understand?
Yes, doctor.
Yes, Doctor.
Okay, now I am going to consider this loop. I am going to consider this loop. That means what is the loop? B, A, D, B, closed loop, because we have to consider the closed loop. So what is my first loop, my dear? My loop 1 is B, A, D and B. I have to close because in a closed loop. What is your second loop? B,
B,
D, C, B. Am I right? Am I right or not?
yes.
What is your third loop? The complete loop. What is your third loop? B, A, D, C,
C, B.
B. Clear? Clear?
Clear, Doctor.
Okay, now, my dear, what, my dear?
Can you repeat it how you name
Okay, I have 3 loops. Just before I told you, this is my first loop. Am I right?
Yes, doctor.
Am I right or not? So
Yes.
point A, C, sorry, point B, A, D, B is my first loop. Am I right? Clear?
Yes.
Okay. Now I will. What is your second loop? What is your
B.
second loop? This is your second loop.
B, D, C, B.
B, D, C, B. My dear, why I am just ending with B? Because you have to consider the closed loop. That's what I start with here. I will end with here. Do you get my point?
Yes, yes.
Okay. What is your third loop?
B, A, D, C.
Complete.
B.
B, A, D, C, B. Clear?
Yes, clear, doctor. Thank
Okay.
you.
Now, my dear, listen carefully. Okay. You have two rules. Am I right? Current rule and voltage rule. Am I right or not? Am I right?
Yes.
Okay, my dear, if you want to apply the current rule, it will be only applicable for the multi-loop circuit. Okay, now you can see, first we finish the current rule. What is the current rule? The number of the currents entering the junction, which is equal to the number of the current, algebraic sum of entering the current to the junction, which is equal to the algebraic sum of leaving the junction. Am I right? Okay, suppose if you consider this is your junction, suppose if you consider this is your junction, how many currents entering this junction? Here
Yes,
you have three
sir.
currents, I1, I3 and I2. Which current is going to enter here?
I2.
I2. Which two currents are leaving the junction?
I3 and I1.
So how you can frame the equation? I2 which is equal to I1 plus I3. Am I right?
Yes.
You can see here we have this relation. Clear? You can see here we have this relation. Understand?
Yes.
Either you can consider this junction, or either if you consider this equation, this junction, both will be the correct. Both will give the same answer. So for this equation, I consider B junction. If you consider this D junction, these two currents are entering and this current is leaving. Am I right?
Yes.
So the
And if I
equation will be the same.
And if I consider the A, it will be the same also. Or C.
My dear, whatever the junction you take, it will be the same.
Yes.
Clear? Clear? But the
Yes.
most important thing, the most important equation is related with the voltage. My dear, now listen carefully. Keep this point in your mind. My dear, how many batteries you have in this complete loop? I have two batteries. Am I right? EM of 1 and EM of 2. Am I right? But in the first loop, how many batteries you have?
One.
One. So what is your voltage rule? You have to separate the battery and you have to separate the current and the resistance. Am I right? Am I right?
Yes.
Okay. Now, according to this picture, your current is flowing in this direction. Am I right? You can see the arrow mark. The arrow mark is given here. Am I right? That means the
Yes.
main current is flowing in this direction. My dear, if any current is flowing in this direction, the current value is positive. If any current is opposite to this current, then it will be negative. Clear?
Yes,
Clear?
doctor.
Okay, could you please write? I am going to separate the battery and the current and the resistance. So I have only one battery. So how I can write? E1, which is equal to my direction of the current. This current is also in the same direction. So it has positive. Am I right?
Yes.
Am I right? So
I1 multiplied by R1.
multiplied by R1, and you are just coming here, and this current is opposite to this current. Am I right?
Yes,
Am I right
minus
or not?
I3.
Minus I3 R3. Clear? Clear?
Yes.
Okay. Could you please make this equation to 0? I just move these two terms to the left hand side. What you will get? E1. If you move this I1 and R to the left hand side, this becomes negative of I1 R1. If you move this I3 R3 left hand side, this becomes
Positive.
which is equal to 0. Am I right? Am I right?
Yes, doctor.
What answer we got here, my dear? Both are same. Am I right?
Yes.
Clear? Clear, my dear?
Yes, doctor.
Okay. Now let's we go for the second loop. Now you have to tell the answer. Now you have to tell the answer for the second loop. So now I am going to consider this loop. So this is my battery. So what is the direction of the main current? In this direction, the current is going. Am I right?
Yes.
Am I right? Okay. Now I have to separate the battery. What is our battery here? EM of
E2.
E2. Am I right? Which
Yes.
is equal to, my dear, This is the main
Minus
current, but what is the direction? Minus
I2 R2
I2 R2, and this is
minus
also minus I3
R3.
R3. Clear? Clear?
Yes, doctor.
Okay. If you move this E2 to the right hand side, what you will get, my dear? Minus I2 R2 minus I3 R3. If you move the positive battery to the right hand side, this becomes clear. Clear?
Clear, doctor.
What answer we got here? Understand?
Yes, clear.
Okay.
Doctor?
Now, yes, my dear.
Doctor, why you put negative with I2 R2?
I2 R2, my dear, you can see this arrow mark. This arrow mark is in this direction. Am I right? But what is the direction of this current?
Oh, yes, yes.
It's opposite. Am I right?
Yes.
So that's what I put negative for I2. Clear?
Doctor,
My dear, whenever you solve, please give importance for the battery. Okay? Clear?
doctor, we can change
my
the
dear.
odd sign to positive.
Yes, no problem. If you multiply by negative, what you will get? I2 R2 plus I3 R3 plus E2. This is also correct.
Yes,
Clear? Clear, my dear?
yes, doctor.
Okay, now we come for the big loop. We have to come for the big loop. So now you have two batteries. My dear, this point is very, very important. So please listen carefully. We have to consider the big loop. Am I right? Am I right or not?
Yes.
Okay,
Yes,
how many
doctor.
batteries you have? How many batteries you have?
2.
Okay, which batteries you are going to give the importance? According to the picture, there is no information about the value of the battery. Suppose I have E1 12 volt battery, E2 5 volt battery. Which one is greater?
1.
12.
Then you have to consider the direction of the main current will be in this side. Okay?
Yes,
Clear, my dear? My dear, this is very, very important point. Listen carefully, because we are going to solve two questions in this chapter with the two batteries. When you have two batteries in the circuit, please keep this point in your mind. Give the importance for the greater battery. Clear?
yes,
Okay, now I am going to consider the direction of the current will be in this direction. So how many batteries you have? So if you just consider this is the positive, I am going to separate the batteries first. How many batteries I have? My E1 is positive. What is my E2? My E2 is moving in this direction. Am I right?
yes,
What is the value? Positive or negative?
negative.
Ah, very good. Okay, which is equal to, now we have to consider the current. So the main current direction is given here. And what is the direction of this current? It is also in the same direction. So positive or negative?
Positive.
Positive.
Okay, now you come here because the current will be flowing like this. Am I right?
Yes,
Yes.
Okay, this current is also in the same direction of the current. What is the value of this I2? Positive or negative? So I have to write I1 R1 plus I2 R2. And now if I just move this I1 and R1, I2 and R to the left hand side, if I want to equate this equation to 0, so how I can write, my dear? E1 minus E2 minus I1 R1 minus I2 R2, which is equal to
0. Doctor,
yes.
what about I3?
My dear, we consider only this loop, so this part is not included.
Yes, yes, clear.
Clear? We consider the main loop outside, complete loop. So if you consider that, I3 and R3 will not play here. Clear?
Yes, and E2 it's negative because it's the opposite direction.
Yes, yes. Okay, now you can see we got the same equation. Clear? Clear, my dear? Clear?
Clear, doctor.
My dear, in this way, you have to frame the equation. Circuit diagram will be given and you have to see the diagram and you have to work out. The most important thing, if your equation is right, Everything will be right. If you made a sign problem, for example, I1 negative, I1 positive, I2 positive, suppose if you change the sign, what will happen? The entire answer will be wrong. So please, my dear, consider this concept, keep this concept in your mind. Whenever you are going to frame the equation, see the direction of the current, and you have to give the importance for the battery. Which direction the battery sign will be there? That is the main current. Clear? Clear, my dear?
Yes, Doctor.
Clear? Okay. Now I will come back for the resistors in parallel and series. My dear, I have to open one more slide. Now I have to ask one question. The question
I have
what
a
we...
question.
Yes.
Doctor, why in the first we use absolute not in the first, and the second one we don't use?
Which one? Which one?
I mean here in this figure we
Okay.
use absolute not, okay? But in the second,
This is it's not a epsilon. This is a EMF. You should not say epsilon. You have to say it's a EMF. Okay. You have two EMF. Am I right?
yes.
Okay. Which one you are saying? EMF 1 or EMF 2?
Two of I mean here we use in this formula, right? But
Okay.
next slide we don't use. Why here
Which
we
slide
use
you are saying?
next, could you go next slide?
This one?
Not this. After this. After this, yeah. No, back, Doctor.
My dear,
the black
you are
one.
saying forward or backward?
The black one, Doctor. Yes, this. Back.
This one?
No, before. After this, sorry.
Okay, here?
The black one.
Which black you are saying?
Now we will explain the parallel and perpendicular, right?
Series,
Oh.
Doctor.
Oh, you are saying this one?
Yeah, I mean this. Serious.
My dear, this is also E1, this is also E2. So don't break your head, okay?
I can change like this.
Yes, my dear, actually in this chapter you have to use, my dear, your epsilon. What is written here, my dear? What is written here?
No.
Clear? Understand?
Clear.
So
Understand.
your
Doctor.
voltage is nothing but your EMF. So don't break your head by yourself.
Okay.
Okay.
Now I
Now,
got it.
my dear,
Thank you, Doctor.
now I need the answer from your side. We studied capacitors in parallel and series. Am I right? Am I right? My dear, capacitance in parallel and series we studied in chapter number 25. Do you remember that?
Yes.
Yes.
Okay.
Yes.
If you have capacitors in parallel, which one will be the same? Which one will be the different? If you have the capacitance in parallel, your voltage is same. Am I right?
Yes.
And your charge is
Different.
Am I right?
Yes, Doctor.
Am I right or not?
Yes.
My dear. Okay. If you have capacitance in series, it's a reverse. Your charge is same. Your potential is different. So it will be the same for the resistance. Suppose if you have a resistance in parallel, which will be the same? Which will be the same?
Voltage.
Voltage will be the same, but your current is different. If you have resistors in series, your current is same, but your voltage is different. My dear, keep this point in your mind. Understand? It's a 1 mark theory question. Suppose they ask, if you have the resistors in parallel, what is the voltage across each capacitor, whether it is same or not? You have to say, if the capacitors are connected in parallel, you have to say the voltage across the capacitors will be the same. Likewise, the same question we can ask for the resistors also. Understand? Okay, now we come back here. What we said, my dear, we are just going to study this concept. Which one is same? Voltage is same, current is different. Am I right? So I can write my current, which is equal to I1 plus I2 plus I3. Am I right? Am I right? Am I right or not? My voltage, which is equal to V1, which is equal to V2, which is equal to V3. Am I right?
Yes.
Now I am going to apply the Ohm's law. What is Ohm's law? V is equal to IR. Therefore, I is equal to V over R. Am I right? Am I right or not?
Yes.
So substitute this I value here. The first equation, the first part becomes V over R, which is equal to V1 over R1 plus V2 over R2 plus V3 over R3. Am I right? And we said V1, which is equal to V2, which is equal to V3. So I can write V over R, which is equal to V over R1 plus V over R2 plus V over R3. Am I right? Am I right? I can take this
Yes.
V outside. If you take V outside, what you will get, my dear? V 1 over R1 plus 1 over R2 plus 1 over R3. Am I right? Now I can cancel this V with this V. What is remaining, my dear? My total resistance equivalent, which is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the rule for capacitors in, resistors in parallel. Clear? Clear, my dear?
It's the same for capacitance, right, Doctor? 1 over
Yes, we
C.
studied in the capacitance. We are using the same thing. There we are using the capacitance of the capacitor. Here we are using the Ohm's law. That's it. Clear? Okay. Let's become for the capacitors, resistors in series, which we say I, which is equal to I1, which is equal to I2, which is equal to I3. What is different? My V, which is equal to V1 plus V2 plus V3. Now I am going to use this equation. My V, which is equal to IR, so I am going to substitute here. What you will get? What you will get, my dear? I multiply by R, which is equal to I1 R1 plus I2 R2 plus I3 R3. Am I right? And my I1, which is equal to I2, which is equal to I3. So how I can write? I can write I multiply by R1 plus I multiply by R2 plus I multiply by R3. If I take I outside, IR, which is equal to I multiply by R1 plus R2 plus R3. Now I can cancel I here. So what is remaining? My equivalent capacitance, which is equal to R1 plus R2 plus R3. Clear? Clear, my dear?
Clear, Doctor.
So that information is given here. So this is the formula. My total resistance when connected with series, this will be the rule, and my total resistance if it is connected with parallel, this will be the rule. So we gave the same. So this is for resistance, this is for parallel. Both are exactly the same. Clear? Clear, my dear?
Clear, Doctor.
Okay. Now we come for our last topic. Charging and discharging of the capacitor. My dear, I would like to remind you about your experiment. You did already the discharging of the capacitor. Am I right? Am I right or not? Am I right or not?
Yes.
Okay.
Yes,
My dear, what you did in that experiment, initially you set 10 volt in the battery and you move the switch to the on mode. Am I right? When you just move the switch to the on mode, whatever the voltage you applied in the battery, it will be exactly shown in the voltmeter. Am I right?
Yes.
Am I right? And when you just turn the switch to the off mode, what happened? Whatever the charge you stored in the capacitor, which will be decreased. Am I right?
Yes, Doctor.
Okay, now you can just study that equation, the main equation. My dear, this is our circuit diagram. My dear, listen carefully. This is our circuit diagram. I have two-way switch. What is the two-way switch? If you connected A with this S, what happened? The battery will provide the charges to the resistance and the capacitance. Suppose if you remove this, if you connected B with the S, what will happen? Whatever the charge you stored in the capacitor, it will be utilized by the circuit. So you have two circuits here. The one circuit, if you connected A with S, another circuit, If you connected with B with S. Clear? So when you connected the circuit with A with S, what will happen? Again, you have to frame the equation. Again, you have to frame the equation. My dear, I need the answer from your side. So if I connected A with S, what will happen, my dear? Again, apply the voltage rule, battery, and then I have something. So battery I am going to separate, which is equal to current multiplied by resistance. Am I right? Am I right or not? Am I right or not?
Yes.
Okay. What is the voltage across this capacitor, my dear? Could you please recall the capacitance of the capacitor? C, which is equal to Q over B. Am I right? Therefore, my voltage, which is equal to Q over C. Am I right?
Yes.
So the voltage across the capacitor is Q over C. Am I right? If you just move these two terms to the left hand side, what you will get, my dear? EMF minus I multiplied by R minus Q over C, which is equal to 0. You got this equation. Am I right? Am I right or not?
Yes.
Now we have the formula for the current. Current I, which is equal to dq over dt. Please take this rule and please substitute here. If you substitute, what will happen? EMF minus dq over dt multiplied by R minus Q over C, which is equal to 0. Am I right? And this is the equation for the charging equation. My dear, the solution for this equation, the solution, that means the final answer, this is the main equation. The final equation for this equation is this one. So if you, the solution for this equation, this is our previous equation, this one. Okay, the solution for this equation is this one. What is given here? My final charge, which is equal to my initial charge multiplied by 1 minus e power minus t over tau, and this tau is called as resistance multiplied by the capacitance. My dear, if you charge the capacitor with the charge, what will happen? Your graph will be coming like this. Am I right? Am I right or not?
Yes, doctor.
Okay, now the explanation how we got this equation, because this is our final equation. In the exam, you have to memorize this equation. So how we got this equation from this? The explanation, I just work out everything. So this is our main equation. I do a small integration work, and then I apply the natural logarithmic rule, and then I just rearrange. And when you rearrange, finally you got this equation. And here RC is nothing but tau. Clear? So this explanation for this equation is given here. Brother, this is a very basic integration work. You already studied calculus 2. And please, my dear, if you find time, just try to have a look of this equation. I'm just substituting the explanation step by step. I'm not skipping any steps here. But you have to memorize this equation. So what is this equation? This equation is for
Charging for capacitor.
charging of the capacitor. Likewise, if you make the connection with B2S, what will happen? Whatever the charge you stored here, and this current, this charge will be moving in this circuit. So by the time, what will happen? Your graph will be decreasing. That means the charge in the capacitor will be decreasing. Am I right or not? So in the charging, your graph will be increasing. In the discharging, the graph, the charge value will be decreasing. So if you just frame the equation like what we did earlier, and you will get this equation, and the solution for this equation is this one. Clear? So how we got this? I explained here everything clearly. But my dear, listen carefully. In exam, we will not ask you to derive like this. The only thing, you have to memorize this, and you have to use this equation. So you have two equations. What are the two equations? For charging the capacitor, what's the rule? Clear? Clear, my dear?
Yes, doctor.
But what is this R multiplied by C? So if you replace this R multiplied by C, how you can write? Q, which is equal to Q naught 1 minus e power minus t over tau. Okay, because our tau is equal to R multiplied by C. What is the discharging of the capacitor? This is the rule. So if you replace this tau with RC, what you'll get? Q, which is equal to Q naught e power minus t over tau. Keep these 2 points in your mind. Okay, clear, my dear? Clear?
Yes, doctor, it's clear.
So chapter 27 is over. Chapter 27 is over. Inshallah, tomorrow we have one period. I will try to finish this problem. Suppose if I can't, inshallah, week number 13. Week number 13, we have 2 classes. Am I right? Am I right or not?
Yeah.
We have 2 periods in Sunday and 1 period in Monday. And these 2 days is not affected with our Ramadan. We will get the full time. It is not half an hour. We will get the full time. Inshallah, I will try to finish the problem by tomorrow. If not, inshallah, I will finish next week. Clear? Clear, my dear?
Thank you, Doctor.
Inshallah.
Clear?
Clear.
Inshallah. So, okay, my dear, listen carefully. My dear, listen carefully. Again, I will tell you the clear picture about your exam. For your exam, we consider from chapter number 16 to 27. Clear? And up to midterm portion, less weightage will be given from quiz 2 to the last chapter, because this time we are going to cut 3 chapters.
How
What?
many chapters they remove?
3 chapters. 28, 29, 30 we remove.
Wow.
Continue, Doctor.
Clear? What, my dear?
You said something about the quiz.
My dear, from the first chapter, that means up to midterm, less weightage will be given. Okay, I'm talking about the marks. Less weightage will be given up to midterm. Clear? From quiz
Yes.
2 portion and the remaining chapters, we will give more weightage because we cut 3 chapters. So this time also we have to include the quiz 2 also. Okay, quiz 2
Yes,
chapters.
yes.
So please prepare well, try to get good marks, and the question will be very easy. And inshallah, regarding the backtracking, I will discuss, and once they give the clear picture, I will post the announcement in the blackboard. Clear?
Thank you very much.
Okay, Doctor.
Clear, my dear? Any question?
it will
Any
be,
question from your side?
Doctor, I don't understand what you said about the final, the last thing. You said something.
My dear, up to midterm, I'm talking about the mark wise, okay? Up to midterm, less weightage will be given. Questions will be there, but less weightage. Clear?
Okay, clear.
But after the midterm, more weightage will be there.
Okay.
Doctor,
Yes.
when will you tell us how many questions and
My dear, still we have time. Don't worry. Maybe within this week we will get this information, or else inshallah I will give you the information by next week. Okay? Clear?
Clear, Doctor. Thank you.
Okay, brother. Thank you so much. Inshallah, see you tomorrow. And we have the discussion class today. If you have any doubts, please come to our class by 2 o'clock. Okay? Clear?
Clear, Doctor.
2 to
Thank you,
2:30. My dear, 2 o'clock to 2:30, I will be in the online. Suppose if no one will be there, I will quit from the room. So please, my dear, attend earlier. Okay?
Okay, Doctor.
Assalamu alaikum.